A raccoon finds a piece of food. It picks it up in its front paws and carries it to the nearest stream or puddle or water source it can find. Then it crouches at the water's edge, dips the food in, and rubs it carefully and methodically between its front paws before finally eating it. We have watched this behavior for centuries. We named it washing. We assumed we understood what we were looking at. But raccoons dip perfectly clean food in water, food with no dirt on it, no contamination, nothing that needs removing. They wash it anyway. They will rewash food they have already washed, repeatedly. And most strangely, researchers observing raccoons in captivity without access to water found that when no stream or bowl is available, the raccoons perform the exact same careful rubbing motion over dry ground with their paws and with nothing held between them. The same motion, no water, no food, nothing to clean, and yet the motion continues. That dry rubbing is the key that breaks the washing explanation apart. If this behavior were about hygiene, about removing dirt, bacteria, parasites, anything contaminating the food, then it would require water to function. Rubbing dry food over dry ground removes nothing. But raccoons do it anyway, which means the water was never the point. Something else entirely is happening, and it has nothing to do with cleanliness. The raccoon's front paws are one of the most remarkable sensory structures in the mammal world. They contain roughly 4 times more sensory neurons than the equivalent paws of most other similarly sized mammals. The density of nerve endings in raccoon paw skin is comparable to that found in human fingertip skin, which is the most densely innervated skin on the human body, the most sensitive surface we have. The raccoon's brain reflects this investment in its paws. The area of the cortex dedicated to processing sensory information from the front paws is disproportionately large, comparable proportionally to the area the human brain dedicates to processing sensory input from the hands. For the raccoon, the paws are not just tools for grasping and manipulation. They are its primary interface with the world. Now, what does water actually do to the paw when the raccoon dips it in a stream? It does not improve sensitivity by a small margin. It improves it dramatically. When the skin of the paw is wet, the mechanoreceptors and tactile nerve endings in the skin become significantly more responsive, better able to detect fine surface texture, microscopic irregularities, the precise shape and internal structure of whatever the paw is pressing against. The scientific name of the raccoon, Procyon lotor, literally means the washer in Latin, and in German, the word for raccoon is Waschbär, washbear. The name stuck across languages because the behavior looked so unmistakably like what it looks like. But researchers studying raccoons without access to water found something that dissolved the explanation. The behavior continued. The water was not the mechanism, it was a tool. The raccoon is performing a tactile examination before committing to eating. Its wet paws are reading the food, extracting detailed information about texture, moisture content, surface consistency, structural integrity, the presence of shells or bones or embedded parasites, all through touch, at a resolution and speed that visual inspection from the outside cannot come close to providing. The raccoon lives as much through its paws as through its eyes, perhaps more so in many environments. Raccoons are highly capable of finding and identifying food in conditions of complete darkness, submerged in mud, beneath still water, inside narrow crevices, entirely inaccessible to vision. Their paws navigate a tactile world that is invisible to us and that their eyes cannot reach. Studies conducted by ethologist H.B. Davis in the early 20th century and replicated and extended by subsequent researchers showed that raccoons can solve complex mechanical puzzles to obtain food, using their front paws to manipulate locks, latches, and fastening mechanisms with methodical persistence. They consistently outperform many primate species on fine motor tactile tasks. The paw is not just a hand, it is a thinking tool. The raccoon's extraordinary success in urban environments is partly a story about this sensory capability and the learning speed it enables. Bins, locks, latches, packaging seals, child-proof containers, all of these are tactile puzzles. The raccoon's paws are not just sensitive. They are dexterous, manipulative, and connected to a brain that processes tactile feedback rapidly and builds procedural memory from it. Once a raccoon learns how a particular latch works, it remembers. Now, the dry rubbing, which is the final piece. When there is no water available, raccoons still perform the same rubbing motion. Not because they are going through the motions out of habit or confusion, because the rubbing motion itself, paws pressed together and moved against each other or against a surface, activates and mobilizes the tactile receptors in the paw skin, increasing their sensitivity even without the amplifying effect of water. They are warming up their hands, priming the instrument, preparing to read. The behavior that looks exactly like hygiene is actually sensory priming, the preparation of a sensory instrument before use. The raccoon is not cleaning its food before eating it. It is calibrating its primary sensory system before conducting an inspection. The water, when available, amplifies the inspection's resolution. The rubbing, always available, makes the inspection possible in the first place. Consider what the raccoon actually knows about a piece of food before it eats it. Texture across the entire surface, whether the skin is intact or broken, whether there are internal voids that suggest rot, whether the moisture content is normal or abnormal, whether a shell contains anything or is empty. All of this from seconds of tactile contact. We named this behavior washing because it looked familiar from our own experience. The motion matched something we recognize. We assumed the animal must be doing what we would do in a similar situation. But the raccoon was never thinking about cleanliness. It has no particular concern with removing dirt before eating. It was gathering information, and water was a tool for gathering it better. This is one of the more common patterns in animal behavior research. A behavior that looks like something familiar, gets named after that familiar thing, and then turns out to be something entirely different when examined closely. The raccoon and the washing is a particularly clear example. The name was wrong for over a century before anyone looked carefully at what happened when the water was removed. The next time you see a raccoon near water, or catch one in your bin at night, front paws working at a latch with what feels like unsettling precision and patience, what you are watching is one of the most sophisticated tactile sensory systems in the mammal world in active operation. It is not washing anything. It is reading everything it touches at a resolution we don't have and can barely imagine. That raccoon at the stream from the beginning, rubbing the food methodically between its paws in the water, looking for all the world like it was washing, was not cleaning anything at all. It was reading a world that is inaccessible to us, through receptors we don't have, at resolutions we can't reach, extracting information from a piece of food that we could stare at for an hour and know far less about than the raccoon knows in 10 seconds of touch. If this changed how you see the next raccoon you watch, or made you wonder how many other animal behaviors we've named after the wrong thing for a century, subscribe. We keep pulling apart the hidden systems behind the wild. The wild mind is everywhere around us. Keep looking. I'll see you next time.